Good morning, all. Myself, Satish Derakene, Assistant Professor in St. Vincent Pallotti College of Engineering and Technology. Today, we will see the problem based on hydrostatic pressure force and its center of pressure. Now, we will see the problem. A circular opening of 3-meter diameter in a vertical side of the tank is closed by a disc of 3-meter diameter, which can rotate about a horizontal diameter. Calculate the total pressure on the disc, means we have to calculate hydrostatic pressure force, that is P, and the torque required to maintain the disc in equilibrium in vertical position when the center of gravity of the plate 6 meter below the water surface. Okay, so for this given numerical, this is the diagram for that. So I am taking one water tank here and a circular opening is this here. So this is the diameter of the circle, that is 3 meter. Okay. So this is the diagram for the given numerical. So we will see the diagram with the help of this statement. 3-meter diameter hole I am taking here. Okay. Is closed by the disc of 3-meter diameter. So this is the one disc having same diameter, that is 3 meter, which can rotate about a horizontal diameter. Okay, so this is the we can apply some force here, that is hydrostatic force for rotation. Calculate the torque, total pressure on the disc. So we have to calculate the total hydrostatic pressure force P and the torque required to maintain the disc in equilibrium in vertical position. Means if we have water here, so obviously there are some pressure acting on the particular plate. So with the help of that pressure force acting on the plate, obviously this plate will rotate something in this direction. It is moving in upward direction. So for maintaining in equilibrium condition, we have to apply some opposite torque for maintaining the plate in vertical condition. Again, I am repeating, we have some water here. Due to some water pressure, whatever the magnitude of force acting on the particular plate, so with the help of that force, this plate moving in this direction, means it is moving up to the right. Means we have to apply some opposite torque to maintain the plate in equilibrium condition in vertical direction. And lastly, one statement is given here. The center of gravity of the plate, means if I am taking, this is the gate here, circular disc here, this is our x-axis and this is the y axis. So obviously center is the center of gravity. Center of the circle is the center of gravity of the particular disc. Okay, so from liquid surface up to this horizontal x-axis, that is our x bar. Means from liquid surface up to the center of gravity of the plate, that is our x bar, and it is clearly given here that depth is 6 meter below the water surface. Means directly the value of x bar is given, that is 6 meter. Now again we all know the equation, the formula for total hydrostatic pressure force, that is P. P is equal to gamma A x bar, means W A x bar. Means the total hydrostatic pressure force P is depend on W, means wet density, that is again it is given here water, so that is 9810. Now area, we have to calculate area of the disc. Also that P is depend on x bar, so x bar is directly given, that is 6 meter. Means initially we have to calculate area of the particular plate. Okay, so this is the very first step, area. It is circular disc, that's why area is pi by 4 d square. And what is the diameter of the plate? That is mentioned here 3 meter. So we can put diameter is 3 meter. So pi by 4 3 square. So this is the area of the plate. Area is equal to 7.08 meter square. Now for center of pressure, again we have to calculate the centroidal moment of inertia. Okay, so centroidal moment of inertia for circle is pi by 64 d to the power 4. So this is pi by 64. D is 3, so 3 raised to power 4. So what is the value of centroidal moment of inertia? Ig is equal to 3.97 meter raised to power 4. So this is the area 7.08 meters square for the circular disc, and this is the central moment of inertia for the circular disc, that is 3.97 meter raised to power 4. Now we know the value of x bar, we know the value of weight density of the liquid, that is for water, and we just calculated the area is 7.08 meters square. So with the help of these three values, we can calculate the hydrostatic pressure force P acting on the particular disc, that is WAX bar. So W is 9810, area is 7.08, X bar is already given in the numerical, that is 6 meter. So this is P is equal to 416,728.8 Newton. Okay, means we can write P is equal to 416.728 kilonewton. This is in terms of Newton. 1 kilonewton is thousandth of Newton divided by 1000. So this is P is equal to 416.728 kilonewton. Means something below the CG, we have this force magnitude, that is 416728 kilonewton acting on the particular disc. Now we have to calculate the center of the pressure. Again, it is immersed in vertically in the liquid. It is clearly mentioned here. 3 meter diameter is vertical side. So obviously plate is submerged in a liquid in vertical direction. So we have to apply vertical direction center of pressure formula. So H bar is equal to X bar plus Ig divided by AX bar. What is the value of X bar? X bar is 6. Center of moment of inertia just we calculated here, that is 3.97. So this is 3.97. Area is 7.08 multiplied by X bar, that is 6. So after solving this, we will get H bar is equal to 6.09 meter. Okay. Now for this given diagram, X bar is 6 meter. And what is the value of H bar? H bar just we calculated 6.09 meter. Means as per this both the answer, this is the position of X bar, center of gravity from liquid surface, and our H bar is 6.09. Means what is the position of this P? This position is below the center of gravity at a distance 0.09 meter, because this X bar is 6 meter and our H bar is 6.09 meter. Means something below the center of gravity, we have this pressure force P. Okay. So I drawn again one separate diagram for the explanation of the particular case. Now what is our aim? We have to calculate torque T to maintain the plate in equilibrium condition. So this is the value of H bar 6.09 meter from liquid surface up to the center of pressure. I am showing here Cp. So this is the P acting on the particular center of pressure from liquid surface 6.09 meter depth, and the center of gravity from liquid surface is X bar, that is 6 meter, is already given in the numerical. So this is our CG, means center of gravity. This is the center of pressure, means CP. So if we know the value of R, means the distance between center of gravity and center of pressure, so easily we can calculate the value of torque. So this is the torque producing one movement, that is in upward direction, up to the right. So if we know the movement produced by or the torque produced by the given magnitude of force P, after that we can apply the opposite torque to maintain the plate in vertical direction. Okay, I am showing here, this is the movement of the plate due to this pressure force P, means we have to apply some opposite torque to maintain in stable condition. Okay, so we have to calculate initially R bar, R distance. Okay, so this is H bar is 6.09 and X bar is 6, means 6.09 minus 6, nothing but the value of R. So this is torque is equal to P multiplied by R. We already completed torsion topic in our strength of material. What is the definition of torque? Torque nothing but the product of force multiplied by some distance. Okay, so that distance I am assuming here R. So this is torque T is equal to P multiplied by R. P is already calculated. Okay, that is 416.728 kilonewton. We have to calculate R. So R is equal to H bar minus X bar. H bar is 6.09, X bar is 6 meter, so R is equal to 0.09 meter. Now we know the value of P and we know the value of R here, so easily we can calculate the torque produced by this force P on the particular plate. Okay, so that is 416.728 multiplied by 0.09. That value is T is equal to 37.50 kilonewton meter. So this much is the torque acting on the particular plate with the help of pressure force P. Okay, 37.50 kilonewton meter means we have to apply one opposite torque with a magnitude of same, that is 37.50 kilonewton meter, to maintain the plate in vertical direction in equilibrium condition. So what is our last answer? We have to apply one opposite torque with a magnitude of 37.50 kilonewton meter to maintain the plate in vertical direction in stable condition, means it is in equilibrium condition. Okay, so this is the value of last answer. This is P is equal to 416.728 kilonewton. This is the position of H bar, means position of total hydrostatic pressure force 6.09 meter, and lastly our answer is torque is equal to 37.50 kilonewton meter. Okay, thank you.